Hi guys, so trig integrals with bounds. For this, your calculator is going to be super useful for sure. Remember that when you're evaluating trig functions, you want to make sure that you have your calculator in radians and not degrees. So at the top right here, when you turn it on, it should say rad. I don't know if you can see that there. I can't wait, kind of sort of there. It should say rad. If it doesn't, then you should press the degree button, this DRG button, until it gets to rad. And that's going to evaluate your trig functions for you. Unfortunately, in this class, decimals are not going to be okay as answers. Some of the trig functions don't give you nice, pretty fractions. And so you really just kind of have to know those. So you have to be comfortable with the trig circle in order to evaluate those. So I've kind of written down a chart that summarizes the trig circle here. The way that I kind of remember it, or like can easily just get it off the top of my head like that, is I have all of the values that matter increasing in increasing order. So 0, pi over 6, pi over 4, pi over 3, pi over 2, and then pi. And then what happens with sine is it goes from 0 to 4 each time over 2. So I can think of like 0 as being 0 over 2, or rather the square root of 0 over 2. 1 is the square root of 1 over 2. Then the square root of 2 over 2, the square root of 3 over 2. And this 1 that we have right here would be the square root of 4 over 2, which just equals to 1. So it goes from like 0, 1, 2, 3, 4. And cosine does the backwards thing. It's like 4, 3, 2, 1, 0. So that 1 is like the square root of 4 over 2, root 3 over 2, root 2 over 2, root 1 over 2, root 0 over 2, which is just 0. So that personally for me is just a thing that helps me to memorize this. Now, how can you use this if you have some of the other trig functions? Unfortunately, or even how can you use your calculator if you have some of the other trig functions? Unfortunately, your calculator only has sine, cosine, and tangent on it, so you really need to know your trig identities that allow you to write the trig functions in terms of sine, cosine, and tangent. So some trig identities that you really should know here, these are called the reciprocal identities, are that sine x is equal to 1 over cosecant x. In other words, cosecant x is equal to 1 over sine x. Cosine x is 1 over secant x. So secant x is 1 over cosine x. And then we already saw that cotangent, or rather tangent x, is 1 over cotangent x, is sine over cosine x, sine x over cosine x, and cotangent x is 1 over tangent x, which is cosine x over sine x. So knowing these identities will help you to more easily be able to plug these things into your calculators and use this table right here to come up with actual values for these things that are not decimals. So I'm going to start off with this simple cosine problem here. I have cosine of 2x dx. Inside, the derivative of 2x is just 2, which is just a constant. So I can just divide by that constant and then apply my known form, which is sine of 2x. Instead of plus c, I'm doing 0 to pi over 4. So this would give me 1 over 2 sine 2 pi over 4 minus 1 over 2 sine of 0. Now, we can plug this into our calculator, but we can also look at our chart up there. 2 pi over 4 is pi over 2. Sine of pi over 2 is 1. So this is like 1/2 times 1 minus 1/2 times sine of 0 is 0. And this just gives me 1/2. So for this one, your calculator would have been absolutely fine. It gives you a nice fraction. There are no radicals involved. Let's do a different one. So I'm going to look at the integral from pi over 4 to pi over 2 of 3 cosecant x dx. And again, I'm keeping it simple to start just because I really kind of want to talk about this plugging in thing. So cosecant is a known form now. It's one of our new ones that we saw in the trig integrals video. So this is going to be 3 natural log of cosecant x minus cotangent x between pi over 4 and pi over 2. So when I plug in, I get 3 ln of cosecant of pi over 2 minus cotangent of pi over 2 minus 3 natural log of cosecant of pi over 4 minus cotangent of pi over 4. Okay, so now I just need to know what is cosecant and cotangent of pi over 4 and pi over 2. So I'm going to go and plug these in on the side. I'm looking for cosecant of pi over 2. Well, I know my trig identity for cosecant is 1 over sine. So this is like 1 over sine of pi over 2. Now sine of pi over 2, at this point you could plug it into your calculator, or we can go up to our little table and see that that is 1. So I'm going to get 1 over 1, and cosecant of pi over 2 is just 1. Cotangent of pi over 2 is equal to cosine of pi over 2 over sine of pi over 2. So at this point, I can plug those into my calculator, or I can just go to the chart up here. Cosine of pi over 2 is 0, sine of pi over 2 is 1. So this is equal to 0 over 1. This is just 0. And now, that's actually really ugly over there. Let me fix that. Minus cotangent of pi over 4. So now we want to plug in our pi over 4s. So cosecant of pi over 4, we're going to do the same thing. This one, if you plug into your calculator, it's going to give you an ugly decimal because sine of pi over 4 is root 2 over 2. So here I will have 1 over root 2 over 2. But we know that division by a fraction is the same thing as multiplication by the reciprocal, so I can just flip my fraction over. Now cotangent of pi over 4 is cosine of pi over 4 over sine of pi over 4. And we can see that at pi over 4, both sine and cosine take the same value of root 2 over 2. So this is just going to be 1. But I'll write it out so that we can see it clearly, root 2 over 2 over root 2 over 2, and that's going to give me a 1. So here, this was how to plug in to the trig functions. So using the table and the identities to plug into the trig functions. Okay, so let's finish this thing. Now I'm going to replace each of my trig functions there with the values that I got here. So this is 3 natural log of 1 minus 0 minus 3 natural log. Cosecant of pi over 4 was 2 over root 2 minus 1. Well, it turns out ln of 1 is just equal to 0. So this is actually just negative 3 natural log of 2 over root 2 minus 1. I'm not going to plug that into my calculator and get a decimal. This is a beautiful, wonderful answer, and I'm going to leave it this way. Okay, so we've kind of seen how to plug in the bounds to the trig functions and how we can use those identities to help us. Let's do 2 substitution problems to see to remember how to deal with bounds in terms of substitution. So C, we're going to look at the integral from 1 to the e to the power of pi sine of ln x over x dx. Here, a good u is going to be to let it be the thing inside that trig function. I also know the derivative of ln x is 1 over x. So u is ln x, du is 1 over x dx. That's my du. So this is my substitution. And now I want to find my new bounds. So if x1 is equal to 1, u1 is equal to ln of 1, which, hey, guess what? We just remembered is 0. So that's a 0 there. And if x2 is e to the pi, don't let that weird value scare you. We're just going to plug it in. We're going to get u2 is ln of e to the pi. And remember that ln and e are inverse functions. In other words, when you see them next to each other, they kind of cancel each other out. And what's left is what you see. So when I cancel out the ln and e, I see that there's actually only a pi left over. So my new bounds are 0 to pi. I replace the 1 with 0. I replace e to the pi with just pi itself. And here I have sine of u du. The antiderivative of sine, be careful, is negative cosine of u between 0 and pi. And remember, these are u bounds. They are not x bounds. So they get plugged into my u, not into my x. So I don't have to rewrite this in terms of x. I just immediately plug in my pi and my 0. So we can go back up to our table up here or use our calculator. Cosine of 0 is 1 and cosine of pi is -1. So this becomes then -1 plus 1 for a final answer here of 2. Okay, so that was a pretty straightforward substitution. Let's go a little bit crazy for the last one. We got this. D. So final question. The integral of sine of pi over 2 tangent x times secant squared x dx, all between 0 and pi over 4. Okay, let's do this thing. So first, what on earth should my u be? So I have secant squared on the outside. That might give you the idea that secant is a good u, but the derivative of secant is secant tangent. That's clearly not there. Inside of my sine, so this is not sine times pi over 2 tangent x, it's sine of pi over 2 tangent x. And inside of my sine, I have another trig function. I'm going to let my u be the thing on the inside. So that's pi over 2 tangent x. So then du is pi over 2, that constant, secant squared x dx. Yay, I have a secant squared right there. I only have to multiply by pi over 2 on the inside, which means on the outside, I'm going to just flip that fraction and multiply by 2 over pi. This is my substitution. It totally works because I have that secant squared there. And now I want to deal with my bounds. So x1 is equal to 0, which means u1 is equal to pi over 2 tangent of 0. So you can plug this into your calculators, tangent of 0, and see that it equals to 0. Or you can remember that tangent is sine over cosine and come and use our table up here. We would have 0 divided by 1, which is just 0. So we can get that there. And then x2 is equal to pi over 4. So u2 is equal to pi over 2 times tangent of pi over 4. Now again, this actually works in our calculators. We're going to learn that pi over tangent of pi over 4 is just 1. Or alternatively, go up to the table, sine over cosine at pi over 4. They're the same. It's just going to give you 1. So this will be pi over 2 times 1, which is just pi over 2. And we're actually going to end up with the same function here. So I'm going to have that this is equal to 2 over pi, the integral from 0 to pi over 2 of sine u du. And we actually now have the same known form as we did in part C, in our part C question. So this is just going to be now 2 over pi times negative cosine u between 0 and pi over 2. And I'm just going to replace that with negative out front to make it prettier and to stop us from thinking it's subtraction by accident. So I'll have negative 2 over pi cosine u, 0 to pi over 2, negative 2 over pi cosine of pi over 2 minus cosine of 0. Cosine of pi over 2, let's go to our charts. Cosine of pi over 2 is 0, and cosine of 0 is 1. So we're just going to replace. We get negative 2 over pi times 0 minus 1 to have a final answer of positive 2 over pi, which I'm not going to write as a decimal. I'm just going to leave as is. Okay, so we've seen how we can do trig with substitution, with the new type of substitution where we let u be the thing inside the trig function. We've seen it with multiple substitutions. We've seen it with reverse substitution where we're letting u be a square root and then squaring both things. And now we have also seen it with bounds. So that is it. All right, bye guys.